Jupiter, the king of planets, a colossal sphere of gas and storms reigning supreme in our solar system, a celestial colossus that has captivated humanity for millennia, from ancient civilizations who saw it as a god, to modern astronomers who study its every detail. It's a swirling vortex of gas and storm, a behemoth dwarfing all other planets in our solar system. Its atmosphere is a chaotic dance of clouds and storms, with the Great Red Spot being the most iconic. Its sheer scale is almost impossible to comprehend. Jupiter is so massive that it could fit all the other planets inside it with room to spare. But Jupiter is more than just big. It's a dynamic world with layers of clouds that tell a story of complex weather patterns and atmospheric phenomena. It's a scientific wonderland, a place of extreme temperatures, unimaginable pressures and powerful forces that defy our everyday experience. The Great Red Spot alone is a storm larger than Earth, raging for centuries. Jupiter's allure lies not just in its grandeur, but in its mystery. The planet's atmosphere is a tapestry of light and shadow, with bands of clouds that shift and change. What secrets hide beneath its turbulent clouds? What drives the immense storms and the intricate patterns we observe? What wonders await within its depths? The deeper we look, the more questions arise, each layer revealing new mysteries. For centuries, these questions have tantalized astronomers and fueled our imaginations, from the early days of telescopic observations to the sophisticated space missions of today. Today, thanks to advances in space exploration, we are closer than ever to unraveling the enigmas of the gas giant. Missions like Juno are providing unprecedented insights, bringing us one step closer to understanding this giant among giants. Jupiter's story begins over 4.6 billion years ago, in the chaotic crucible of the early solar system. This was a time when our cosmic neighborhood was a swirling, turbulent disk of gas and dust, a place of constant collisions and violent interactions. The Sun, still in its infancy, was surrounded by this chaotic disk, a nursery for the planets that were yet to come. As the newborn Sun ignited, it bathed the surrounding disk of gas and dust in heat and light. This intense radiation began to push and pull on the particles within the disk, causing them to clump together and form larger and larger bodies. These early building blocks of planets, known as planetesimals, started to take shape amidst the swirling chaos. From this swirling maelstrom, planets began to form. These nascent worlds were constantly bombarded by smaller objects, growing larger with each collision. It was a violent and dynamic process, one that would eventually lead to the formation of the planets we know today. Jupiter, it seems, was first in line. As the largest of the planetesimals, it had a significant gravitational advantage, allowing it to attract more and more material from the surrounding disk. It greedily gobbled up the lion's share of the remaining material, growing to a colossal size. This process, known as accretion, allowed Jupiter to amass a vast amount of gas and dust, becoming the behemoth we see today. The result is a planet of staggering proportions. Jupiter's immense size and mass have a profound impact on the solar system, influencing the orbits of other planets and even protecting the inner solar system from potential comet and asteroid impacts. With a diameter of 140,000 kilometers, Jupiter is 11 times wider than Earth. Its sheer size is difficult to comprehend, but it plays a crucial role in the stability of our solar system. To put that in perspective, if Earth were the size of a grape, Jupiter would be as big as a basketball. This comparison helps us grasp just how massive Jupiter truly is. But Jupiter's bulk is more than just impressive. It's a testament to its formation. Its massive size and composition provide clues to the conditions of the early solar system and the processes that led to the formation of the planets. This massive world is a relic of the solar system's infancy, a time capsule preserving clues to the very origins of our cosmic neighborhood. By studying Jupiter, scientists hope to unlock the secrets of our solar system's formation and evolution, shedding light on the processes that have shaped our cosmic home. Jupiter may be our cosmic neighbor, but it's a distant one. This gas giant, the largest planet in our solar system, has always fascinated astronomers and space enthusiasts alike. At its closest, it's still about 600 million kilometers from Earth. This vast distance is hard to comprehend, but it's a testament to the immense scale of our solar system. That's over 600 times the distance from Earth to the Moon. To put it in perspective, if the Earth-Moon distance were a single step, the journey to Jupiter would be like walking over 600 steps. Voyaging to such a remote world presents immense challenges. The journey is not just about covering the distance, it's about surviving the harsh conditions of space for an extended period. Even with our most powerful rockets, it takes years to reach Jupiter. The spacecraft must endure the vacuum of space, radiation, and extreme temperatures. Yet human ingenuity is relentless. Engineers and scientists are constantly pushing the boundaries of what's possible, developing new technologies to make these distant dreams a reality. New technologies are emerging that promise to revolutionize space travel. Innovations in propulsion systems, materials science, and energy sources are paving the way for more efficient and faster spacecraft. Micronuclear reactors, for example, could provide the immense power needed for faster, more efficient spacecraft. These reactors harness nuclear energy on a small scale, offering a compact yet powerful energy source. These tiny powerhouses, no larger than a refrigerator, could one day propel us to Jupiter and beyond. With such advancements, the dream of exploring the outer planets is becoming more tangible, bringing us closer to bridging the cosmic gulf. Gazing upon Jupiter through a telescope, we are greeted by a mesmerizing spectacle. Bands of swirling clouds painted in hues of orange, brown and white. This turbulent atmosphere is Jupiter's most prominent feature. But beneath its beauty lies a realm of chaos. Jupiter's cloud tops are a frigid -145 degrees Celsius. Here winds rage at speeds exceeding 300 kilometers per hour, whipping the clouds into intricate patterns. These winds are driven by Jupiter's intense internal heat, which constantly churns the atmosphere. The result is a perpetually dynamic environment where storms erupt with breathtaking violence. Section 5. The stench of a billion volcanoes. As we descend deeper into Jupiter's atmosphere, the temperature and pressure increase dramatically. Around 70 kilometers below the cloud tops, we encounter a layer composed of ammonium hydrosulfide. This noxious compound is responsible for the distinctive smell of rotten eggs. Imagine, if you will, the pungent aroma of a billion volcanoes erupting simultaneously. That's the kind of olfactory assault that awaits us in this layer of Jupiter's atmosphere. The intense heat and pressure here would be unbearable for any human, even in the most advanced spacesuit. Section 6, where hydrogen flows like liquid metal. Continuing our descent, we plunge into a realm unlike anything found on Earth. Here, under crushing pressures millions of times greater than at sea level, hydrogen, the most common element in the universe, undergoes a bizarre transformation. It becomes liquid metallic hydrogen. Imagine a sea of shimmering silvery fluid conducting electricity like a metal. This exotic form of matter is thought to be responsible for Jupiter's powerful magnetic field, the largest and most powerful of any planet in our solar system. Section 7. The Eternal Tempest. No discussion of Jupiter would be complete without mentioning its most iconic feature, the Great Red Spot. This colossal storm, larger than Earth itself, has been raging for at least 300 years. The Great Red Spot is a high-pressure anticyclone with winds swirling counterclockwise at speeds of up to 680 kilometers per hour. Its reddish hue is thought to be caused by complex chemical reactions in the atmosphere. Despite its longevity, the Great Red Spot is not static. It shrinks and expands over time, and its color varies in intensity. Section 8. An invisible shield of force. Jupiter's immense size and rapid rotation generate a powerful magnetic field that extends millions of kilometers into space. This magnetosphere acts as an invisible shield, deflecting harmful radiation from the Sun and protecting Jupiter's moons from its wrath. However, this protection comes at a price. Jupiter's magnetosphere traps charged particles from the Sun, accelerating them to incredibly high energies. This creates intense radiation belts around Jupiter that pose a significant hazard to spacecraft. Section 9. A journey beyond imagination. A journey to Jupiter's core remains a distant dream, a testament to the immense challenges posed by this extreme environment. The crushing pressures, searing temperatures, and intense radiation would push even the most advanced technology to its limits. Yet the human spirit thrives on exploration, on pushing the boundaries of the unknown. Perhaps one day, armed with even more advanced technology, we will finally unlock the secrets hidden deep within Jupiter's heart. Until then, the King of Planets will continue to beckon us, a tantalizing reminder of the vastness and wonder of our universe.